Hi everybody, welcome to part 2 of episode 3. I'm on a short hunt here. You're going to find out why pretty soon. We'll get through this hunt really fast and then we're going to look at the rocks that we found in the first part of the episode and of course the ones you see me pecking out of the mountain right there. And in the last 5 minutes of this video, we'll be looking at our model and discussing the mantle plume colliding with the continent. That's the end of the road. What a bummer.
You're recording. I'm recording you. If you want to say anything.
Okay, thank you. Can you go sideways with it? Yeah. This is, you can see the dike running up through here. I'm going to get a good sample of it. I've never seen a intrusive that was so white. Looks more like a ash deposit, but it's completely vertical. It's a real light color. It's definitely rhyolite. I'm taking this home. Okay, everybody, I'm home. Let's go over the rocks we just found on this short hunt, and then we're going to get to the rocks we found in the first part of this episode. All right, what we got here, I thought was rhyolite, as you just saw in the video, but I was wrong. Looked this up and they say it's cyanite, like we found in the first episode, except for there's no big, large, darker crystals in this. It's not. There we go. And we got the super bright. Boy, out in the sun, it just makes your eyes hurt. Here's a piece cut. That's just dirty water running through there, like rusty water. It's probably a little iron in there. It's rusting. Pretty look to it. Now they say that this rock can come from like a granitic rock. So if you end up with like a, I think this is a diorite, but it's a granitic rock. And let's say it gets heated, but not super hot. It's not melting everything. It's only melting the lighter colored minerals. And the lighter colored minerals, the lighter colored minerals are getting heated up and separating. The darker minerals are staying behind, and you end up with this whiter material on the top. Another way it could be produced is an alkaline injection of magma, and it gets kind of complicated. Let's just go with that for now. All right, let's just jump right in here to some of the rocks we found in the first part of the episode, part 1. This is a beautiful jasper. If you've been around watching since episode 1, we've been running into chert everywhere. This is metamorphic chert. That's what I would say. I would call it jasper now, but if you just saw this video, the first part anyways, you saw chert just being twisted around and squished. And the lighter colored mineral is calcite. Calcite's kind of holding the whole thing together here. Maybe there's a little quartz here. Yeah, it's not fizzing as much as the other is. So it could be agate. It's a silica, it's a quartz. No big deal. There's a lot of silica in that area. But there was a lot of calcite in the area. Just tons of it. I think you saw that in the video. It kind of quite bizarre. It was really fun to walk through. I want to go back on a nice little lightly rainy day. See how everything looks. Ooh, a lot of calcite there. This one, whole thing, I guess it might be a limestone. It's red, it's kind of odd. But if I left this in the acid overnight, there would really be not much left. Maybe a little bit of sand, some mud particles, but it was mostly calcite. This one's a lot of, wow, there's a lot of calcite in there. So this is more like a limestone. It's really red. Interesting. It goes, maybe the calcite separating from the, it could be the calcite separating from the chert as it was being metamorphed. Calcite, very common. Think of limestone. Calcite's limestone. A little bit of acid, that stuff will dissolve and make caverns, and also hot springs can dissolve the calcite, and you'll see travertines from like Mammoth Hot Springs in Yellowstone. I think that's limestone. Yeah. I hope so. Anyways, okay, now I did find the rock I was looking for down there. This is the dated rock. They don't date all the rocks, of course. This one's dated at 30 million years. I believe this is the one they dated. I don't know. There's 4 or 5 intrusions along that beach. And I know that it was a basalt that they dated. There's a little bit of olivine in here. Pyroxenes. Maybe at the end of the video, I'll show some macro shots right at the end there as we finish up. Now that rock I wandered off to and called it green. Well, it's kind of a yellowish green. When you walk up to it, it's red, much like this. A lot of red in there. I'm starting to think it's potassium. When you break it open, you get this pale green from these crystals. I think it might be amphibole hornblende. Not positive. I'll have some fun this winter on the rainy days figuring out exactly what that is. Now, if you can see, these crystals get wet. Let's just do that. When they get wet, what's left of the crystal, I should say, it's just probably just a clay. They will come squirting out of the rock a little bit as the powder expands with the water. I'm sure that's not good for you. That's one reason they teach rock hounds not to lick rocks anymore. It's very dangerous. Okay, what's next? I think we've pretty much gone over everything. Oh, no, I got this one here. Okay, this is my favorite one. Almost forgot it. This, I swear it looks like a camptonite, which is a rare or uncommon volcanic rock. Let's get a good shot of it. You got some swirling there on the left. Pyroxene. Maybe not. Plagioclase, I can see that. Now this rock, sorry about the camera stuff. This one. Oh, haven't shown this one yet. They're all related because I can see they have the same big, long, needle-like crystals that have 6 sides to them. Probably can't see it too well right there. And I think they're all an alkaline intrusive rock. Intrusive rocks can be hard to identify because if they made it to the surface, they'd clearly be a volcanic-looking rock. Usually. But if they don't make it to the surface and they cool really slow, they'll look like a granitic rock. Okay, I wet this one again. Ooh, that you can see the powder clay crystals that have dissolved in there are kind of coming out there a little bit. Sorry about the camera work. I'm working on my light box. Just use this one. This has beautiful, big calcite nodules in there. Also has some white ones here that maybe it's quartz, don't know. I am going to try to figure all that out. Okay, now, sorry about that. That's probably my favorite rock to find. It's got big calcite nodules in it. That could be a secondary deposit, but there must have been some big air pockets in there for them to fill. The yellowish ones are, they appear to be decaying out of the rock. And these holes are minerals that have decayed and eroded out of the rock. Oh yeah, I can see that's gross. It's coming out of that rock. Okay, let's talk about where we're at on the map here. Okay, so the crust has like an upper mantle area. Let's just make it simple. Something like this, okay? And of course my marker quits. Okay, there's like this boundary in here between the crust, the upper mantle, and the lower mantle. And so you throw in a mantle plume that's coming through. Okay? Where's it gonna go? What happens here? This part I find kind of interesting. You got your upper mantle here is going to move faster than your crust. You got this continent moving this way. So you got two plates moving in opposite directions over a mantle plume. But generally, this whole thing is moving into the mantle plume. So what's going to happen? I mean, is it going to get bent over, and then come through shorter up underneath here and leave behind just a plume? Or is it going to come through? Is it going to erupt on the coast because it's trying to push down through here? Now, let's remember from episode 1 or 2, I can't remember, up here in Central Oregon coast, they say that's where Yellowstone first came through. There's the Akats basalts. Waldport's got some interesting alkali rocks like we've been looking at down here near Brookings. See, I've been wondering if it's not connected, but if they're not connected, that's fine. I've collected some really cool rocks and I've learned a lot from them. So what happens here around this 30 million year mark? It's interesting. It's long been known that the Cascades, say around just south of Crater Lake, okay? They quit erupting that much rock. I mean, they kind of slowed way down for a period, and I think that started around 25 million years. While everything north of here was erupting just fine, just normally, it seemed like. When you look at a geological map, you can see the deposits that were left behind. But in this area, in the South Cascades, they kind of quit erupting. And you think, well, how could they quit erupting if there's a mantle plume coming through, right? It doesn't sound like it would make sense, but it does. Because here, if it's coming through here and it's pushing the subducting plate up, then you're not going to get all this melt coming off the top of this plate at about 60 miles down. You're going to have volcanoes that might migrate out as this plate's coming up from the plume. It's all pretty interesting. We're probably going to get into this 100 times. I'm sure a lot of people have been wondering, what about out here, the McDermott area, Steens Mountain, the flood basalts that coming up through here? Well, what they think is about the time Yellowstone got about here, it blew through. Blows right through, finally burns on through, and then all heck breaks loose. I mean, when you look at a geological map, it's just for millions of years. It's amazing. As the mantle plume goes off up underneath Idaho, there's all these massive explosions going on and granitic chambers, rhyolite explosions. It's quite amazing. Maybe we'll get into that when we get done with this first part of the hunt. Okay, what have I forgot to say today? Well, in case I got it all done in the first take, thanks for watching. In the next episode, we're heading to the Cascades. In fact, we're going to be heading right in here, right there, right in the middle of that area. And maybe we'll find something cool. I think we're going to hit a fossil bed on the way up. I found many years ago. And we're going to collect a few basaltic andesite type rocks and put them in the collection so we can compare them all day and one day and take a look at them. All right, thanks everybody for watching.